Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. In the lecture series of MaterialStudio, we are at the lecture number 14, and in today's lecture, we will learn about the Phonon calculation in MaterialStudio. So, how to calculate Phonon dispersion, Phonon density of state, and conductivity by using um, GULP module of MaterialStudio. So, for this, firstly, we have to import any structure from MaterialStudio library, and then the second most important step is to make P1 symmetry. So we know for many simulation it is necessary to convert a high symmetry crystal structure to P1 symmetry. For example, during a molecular dynamic simulation, when the atom will move away from their equilibrium position, and the intermediate position will not satisfy the symmetry condition of the higher symmetry space group, so we have to use P1 symmetry. So for this, click on build, and in the symmetry option we see P1. So firstly we have to impose P1 symmetry. Okay, so after that, let's open the GULP module of MaterialStudio. So you will see the type of interface after opening the GULP module of MaterialStudio. We will find this module easily in the module sections. So from task section, select geometry optimizations. So is it necessary to firstly optimize the material? So GULP has many different force field and libraries which use a variety of techniques, from two body interaction to many body interaction. So as we are working on titanium dioxide, we will use Levy's is better. One can check with Burner or Burner 1 or Bush. So there are so many force field as the material contain titanium and oxygen. So for titanium and oxygen, Levy's force field is better. After clicking on more, you will see again some options: constant volume optimization, constant pressure optimizations, and the other conversion tolerance parameters. So one can change these manually. 4 or 5 or 6, it's up to you. Also you can change maximum gradient manually, like for example 6, and parameter 5, maximum function cells from 1000 to onward. Okay, so and from charges we have to set force field assign, as we already assigned Levy's force field. So you have to select force field assign from the charges options, and no need to impose any electric field and field directions. So moving ahead toward the properties selection. So a variety of property can be obtained from GULP calculation. So here we will see several properties available. These are all very quick to calculate on a small system like titanium dioxide. So we can select all these, and in frequency we will see some option, like the first one is calculate frequency dependent properties. Yes. And frequency range, basically we start from 1000 to 1.e to the power 4, 1 per centimeter. So it's okay, start with 1000 and vary step by step. Frequency step, better is to start from 50. It's a very good choice. Again, we have option for phonons. Here we found dispersion and DOS, density of state. Either we have option if we want to calculate dispersion and density of state at once, so we have to select these options. And the last one is about conductivity. So firstly we have to calculate dispersion, phonon dispersion and phonon density of state, and then we will move ahead towards the DAS of the desired material. So if one can interested in creating a path, so here is the path for the TJ. Okay, so the third option is job control. So you have to set only one core because GULP does not allow us to apply parallel cores, so we have to set only one cores. And from the more section we have to select retain server file, because sometimes the job is filled, so we have to recognize it. Okay, simply click on run and job will get started in a few seconds. Like I already calculated phonon dispersion, phonon density of state. So we see our job has been completed. So how to analyze? So for this, again open the GULP module and click on analysis, and then click on phonon. So here we have option phonon dispersion, phonon density of state. Here we have 3 units for the graph. For the analysis, so firstly we analyze the phonon dispersion, and then we analyze phonon density of state. So this is how you calculate phonon dispersion, phonon density of state by using GULP module of MaterialStudio. With this, thank you very much. If anyone have any question, feel free to ask.